We're going to tackle my readings first. It was 3 articles, actually it's 3 columns I wrote in sequence, because I think the issue is in some respects more important than the peopleware issue. The peopleware stuff is very important too. We'll do that, we'll take roll, we'll do peopleware, and see how quickly we can get you out of here today. Lies, damn lies, and project metrics. Mark Twain liked to quote British Prime Minister Benjamin Disraeli as saying there were 3 types of lies: lies, damned lies, and statistics. Truth that still holds true today. Particularly, how many of you take, what do you have to take? 321, Stat 321? 121. Oh, you have 120. Lower division. Oh. Let me tell you, a good grounding in statistics is a good grounding for life, because you will look at almost everything you see in the press with great skepticism from now on. It's like, okay, this is what this poll says. What was their sample size? How are they controlling this? What are they doing here? There are, and the other thing you will discover, and there's a number of articles that you're interested in, you'd be stunned how many scientists have a poor grasp of statistics. How much p-hacking there is in science to try and get publishable results. A lot of stuff that comes out in science is frankly not terribly well supported or documented. And it's usually through misuse of statistics, but that's a whole other lecture. Okay. Now, the problem, we've talked about all the difficulties there are in project estimation. Project metrics are usually an attempt to do project estimation in the middle of a project. You're trying to answer the question, when is this going to ship? Or how far done are we? Or how hard are people working? And sadly, almost all the metrics that are used are bad. Some are not terribly informative, others are actually distorting. For example, we'll talk about a few of those. A useful project metric has to have 3 qualities. It has to be informative or predictive. It tells you something important and or when you will deliver, which is usually something important. It has to be objective. That is, it shouldn't matter who is producing this metric, you should get the same answer. And preferably it has to be automated. In other words, it has to be done quickly and with little or no human intervention. And the key issue here is almost all major project metrics lack one or more of those qualities. And they suffer as a result. Okay, metric loss. Jerry Weinberg, just passed away. So sorry. Great man. That which gets measured gets fudged. People will gain metrics. And actually, the book, I'm going to cite, let's jump to the bottom one. The book by Robert Austin, Measuring and Managing Performance in Organizations, does a detailed modeling from both a mathematical and a philosophical sense of why trying to manage by metrics almost always goes bad. Because what you end up doing is simply creating an incentive for achieving the metric as opposed to achieving the actual production goals that you want. Metric law of 90s, we've already quoted this. I didn't make this up. This has been around for decades. You know, the first 90% of the project takes 90% of the time. The remaining 10% takes the other 90% of the time. This is the issue we've already talked about. We go after the low-hanging fruit. We push all the hard problems to the end. I can't tell you how many times I have seen this. In projects I have gone into review, either as a consultant or as an expert witness. And what you end up with are projects that never stabilize. Because they basically have chosen, remember the PERT charts where we saw lots of parallel paths and then all coming together at the end? Well, a lot of projects are like that. What you have happen is that you've got some number of parallel paths which are all doing the low-hanging, easy fruit. They're pushing off the hard problems. And then you get to that point where they all have to talk to each other again. And not only have all the hard problems been delayed until then, but often the solutions that have been picked in those paths are incompatible with the set of hard problems that remain. You have, in other words, I've done a particular approach on this path, and I've done another approach on this path, and I've got a hard problem on this path, and the approach here doesn't allow it. So now I have to back this up and undo my solution. Most organizations won't do that. They'll keep trying to push ahead. And this is why you see this pattern, which I've seen over and over and over again. Come up to a deadline, slip. Come up to a deadline, slip. Come up to a deadline, slip. And you never go into production. I call the pattern the never-ending story. It happens all the time. This is how you get projects that, you know, spend tens, hundreds of millions, billions of dollars, and then get abandoned because they've chosen the wrong paths going forward. Metric law of least resistance. The more human effort required to calculate a metric, the less often and less accurately it will be calculated. Until it's abandoned or ignored altogether. This is, you know, you have the old joke with the drunk who's on his hands and knees under a lamppost. Someone comes along and says, you know, can I help you? He says, yeah, I lost my car keys. And the guy gets down, starts looking for him. He said, well, I can't see them anywhere. He said, well, actually, I lost them over there, but there's more light here. We often do that with metrics. We pick metrics that are easy to do, that aren't informative, and we end up looking at in the wrong place for the actual issues. So here's the basic challenge up at the top. You started the project, you're somewhere in the middle, which is where all of you are right now, and you're trying to estimate what it is. Let's talk about each of these. Why is project completion hard to estimate? Because you often still have analysis that needs to be done. In fact, if you're doing any sort of iterative or incremental project, you almost certainly have analysis that needs to be done. Because you're trying to do a design a little, code a little, test a little phase, which is a good thing to do, but you often do not have a good handle on how much analysis you still have to do. Once again, we're back to armor, the amount of invention, novel problem solving that still has to occur. You don't know what you don't know. You have sort of these dark clouds on the horizon saying, yeah, that's a problem we're going to have to deal with. We're going to figure out how to solve that. Some of you have actually stated this in your status reports. It's kind of like, hey, we see problems here. We're not sure how we're going to solve them. And chances are, given the time frame here, you're not going to solve them. The amount of discovery that still has to occur. And that's sort of tied to the amount of invention. But you may even have a solution. You know what you want to do. You know the approach you're going to take. And you start working on it, and you discover that you're maybe 2 orders of magnitude too slow. We know how to do this. We can calculate this. We can calculate this, but we can't do it fast enough. You know, we need half a dozen processors working in parallel in order to actually accomplish this. The adequacy of the current architecture, design, and implementation. This comes with if your original architecture and design and implementation approach are not sufficient to achieve your solution space. And you only discover that partway through. It's kind of like, oh, you know, we're going to have to rework something, we're going to have to redesign this. Sometimes it's hard to predict how much coding you still have to do. we often tend to think of problems in terms of a simple matter of programming. You know, you can say, well, I understand the architecture, I know the design, you know what I have to do? I can code this up in 2 days. And a week and a half later, you're still writing code and trying to get it to work. The amount of software quality engineering that still has to occur. This is the 3-week of testing fallacy. I've mentioned that before. When at Pages we closed on funding, brought Larry Spellhog on board, great CEO. I have tremendous respect for him. But like I said, I was trying to hire a director of quality. Larry said, can't you just hire some college students to test the last 3 weeks before we ship? It's like, no, Larry. That won't work at all. And we hired a director of quality, we hired full-time quality engineers, and they still were kept busy full-time for a year and a half. But this is where management will start to skimp. They'll want to do minimal testing. We'll let the users find the bugs. You know, we'll push this out and we'll let the users find all the bugs. But even the users won't necessarily find the bugs. Oops. Perfect. It's hard to predict all remaining external dependencies. You may be counting on a release from a vendor of a particular software tool or utility or API or project that you're doing. You may be having to interface with an API from some other organization. You may have other projects in-house that you're waiting on. You know, someone else is doing if someone in-house is building a data warehouse and your project is dependent on that warehouse being built, and now suddenly you get to a certain point and pretty much tied to waiting until they're done and have it working correctly, and that they didn't change the API. It's often hard because of the talent, experience, and productivity of the IT engineers and managers, as well as turnover. You know, you have someone who's your specialist on a particular chunk of it, and she gets a better job offer and leaves. Now suddenly you have to replace her and bring whoever the new person is up to speed, capture all the stuff, and you don't know, the engineer who departed, you don't know what all she was carrying in her head. And so you have a repetition of a lot of the trial and error that your original engineer went through. This change management is an important one for when you're doing applications for in-house use. The amount of business process re-engineering required to put the system into production, as well as the amount of resistance or cooperation needed. 74, I'll keep saying, people hate change. People hate change. You get used to your operating system, you get used to your application. I continued to use Office 2003 for about 10 years after subsequent versions came out, because I really didn't like the ribbon interface and all the changes Microsoft made to Microsoft Word. I've been using Microsoft Word for 30 years. And we finally reached a point where they were no longer updating it, and my installation keys wouldn't work and so on. Finally bit the bullet, and now I'm on Office 365. But I still swear at Microsoft. It's like, why did they change it? I really like the old interface. It's often hard to predict the complexity, cohesion, and comprehensibility of the overall system, which again has impact on both adding additional features and finding and fixing bugs. And of course, you may have scope creep. New requirements added. Conflicting requirements. It's kind of like, okay, it has to have microsecond response time, but we need to support 1 million simultaneous users. Changes in business and market needs. Competing products coming out. Budget constraints or internal politics. How many of you have had experiences with any of these issues? I mean, okay, anyone want to tell stories? You promise want to tell. Yeah.
I was working on that algorithm for the back end and the front end people think about things being very, very fast and updating on lots of things. And so they have these ideas about how fast it has to be, and I just try and convince them that it's not going to work like that. But they plan their front end around it being so fast and updating so many things that they're optimistic, I guess.
Yes, because they're not having to make it work. Other stories, anyone? Yes?
I was working on a project where I was doing something with machine learning, and my manager comes back to me. I show him how it all working. He goes, okay, so how is it learning from the user? I'm like, no, it already did the learning. Oh, why? He's like, oh, but I want it to actively learn from these. I'm like, no, that's not what this is. Like, that's exactly different.
Yeah. Other experiences, yes.
We were on a mainframe, and we were told that rather than fixing our code, we wrote an emulator to run mainframe code, machine code, so that we could then integrate it with modern languages. So we didn't have to rewrite the stuff that was running in assembly. We could just keep running that and then write new stuff in the new language, and they could talk to each other. So we spent a whole, I don't know, like 4 or 5 years as a company writing an emulator for assembly code, for mainframe.
Oh.
Whereas a straight rewrite probably would take a fraction of the time. Yeah. Anyone else want to throw in your own horror stories for this stuff? Yeah.
I once had a project I was working on, and the requirements were set by one of the executives in this company. And I kept on presenting to him, and every time I presented to him, I would come back with 15 new things that I had to fix on it. And even if I had done it before, and then he said the next time, oh, I don't want that actually. Next time comes back, and he's like, oh, we do want that. Where is it? Just make up your mind.
Yeah. So this is why project completion is hard. Now, the question is, what metrics do you have to predict any of that? How do you craft metrics that say, oh yeah, we're going to be done on date X because we anticipate that the manager is going to keep changing his mind back and forth about a given requirement. Or because, yes, we have to make a mainframe assembler code emulator work. And we're going to build our product on that. Man. Okay. Now, this is an issue I've dealt with all my career, and I don't have a lot of easy answers for metrics. This is an approach, and this is actually, if you think about it, this is basically a machine learning / Bayesian approach to metrics, which is instrument your project, collect data, metadata on your project while it's in place, and then do analysis after the end of the project to see what characteristic or combination of characteristics best predicts the completion date of the project. There may not be any. And no one's funded me to actually try this out in real life and see how to make it work. But you're going to be running into metrics, and some of them are going to be as stupid as lines of code. How many lines of code did each programmer write this week? Which is meaningless in a number of senses. Senses starting with the fact that if you're doing any refactoring, you're going to be reducing the number of lines of code. But it's not an effective measure for project completion. I had a case that I worked on as expert witness where there are software estimation models out there. One of the best known one is Kokomo, actually Kokomo 2, by Barry Bohm and a number of people. It's very complex, and its intent is trying to give you a first order estimate of how much effort is going to be required. Now, I had a case that I worked on as an expert witness where there was an allegation of misappropriation of source code. And the expert on the other side said, well, this is 9,000 lines of source code, and he took it and he plugged it into the Kokomo 2 model and said, okay, this 9,000 lines should have taken this long to develop, and with these hourly rates, this is how much the software is worth. And I took the same Kokomo 2 model he did and showed by there were arbitrary decisions he made on some of the inputs. And by changing those, and these were decisions not based on the facts of the case, but him just saying, well, we're going to assume this. So that I could get a 2,500 to 1 variation on the estimate, just because of those base assumptions. So if someone says they have a software estimation model, treat it with a great deal of skepticism, because software estimation models tend to be extremely sensitive to non-objective estimates. Yeah.
I think another problem with metrics is a lot of people try to jump to causality from the metrics. Say, well, we have this data that shows in the past that these things are going well. So if we get people to focus on that, it'll change things, and that usually doesn't actually happen. It's something that yields a metric that you can then observe and say, okay, things are going well or they aren't.
Yeah. And I know I sound like a broken record, but it really does come back to our own. It's why it's the first thing I had to read, and why it's such an important paper, is that, backing up here, when you're at a certain spot and you've got that dotted line there, unless you've done it before, there is a degree of uncertainty, and sometimes a large degree of uncertainty. That's what it's going to take to get the project to completion. Yeah.
I was going to ask if you mentioned in your third reading defect management system, and that was one of your heuristics. I don't know if I know what that is.
Oh, there are lots of applications to allow you to track bugs. It's bug reporting system. So there's lots of different software packages, including a number of free software packages or open source, that basically, when a defect is found, it gets, and frankly, for, again, anything above about 3 people, you should be doing it now. With your short projects, it's not worth doing it. But basically, what you do is, oh, I found a bug. So what you do is you describe, here's a defect, here's what it did, here's how you can reproduce it. Then someone has to assign both the severity and the priority, which are not necessarily the same. Severity is, what's the impact? Well, the whole program crashes. Okay, that's pretty severe. Or it's like, well, there's a miscolored pixel up in the corner. Okay, that's not terribly severe. Now, the priority says, how important is it for us to fix this before the next time? And that's usually a function of the impact on usability of the program and the frequency with which it happens. Yes, the whole program crashes, and this happens to me about once every 2 weeks. Okay, it's a pretty severe bug, but I can live with a crash every 2 weeks. If I couldn't, I wouldn't be using Microsoft Windows. Or it can be, well, there's a few miscolored pixels here. Well, the application happens to be Photoshop. No, I cannot have miscolored pixels on the image I'm editing in Photoshop. So you have those judged, and then typically you have a review process that goes through and says, here are the defects we've prioritized the defects based on both their severity and their critical nature. And we're now going to do that. And what a lot of organizations will do is that really most feature requests are just sort of a form of defect. It's missing this feature. So you'll get, you basically have severe bug, major bug, minor bug, cosmetic, feature request, a continuum like that. And you typically will have a review process that will determine the priority of what needs to be fixed, either adding new features or fixing defects. Okay, so that's the end of that one. We'll turn on the lights, wake y'all up again.